Welcome back. We're going to do the third example here for a double angle identity style of problem. And before we get started here, the information that this problem is giving to us is that the cosine of our angle theta is equal to 5/13. And they're also telling us that theta is between 3/2 pi and 2 pi. So our angle is going to be somewhere down here in the fourth quadrant, somewhere down there. So we have to remember when we're solving this particular problem, we have to recall which particular sine functions are actually going to be positive or negative in that fourth quadrant. So if you use the acronym all students take calculus, in the fourth quadrant the only trig function that is positive out of the main three is the cosine. Keep that in the back of your mind. Alright, so remember, cosine of theta is equal to 5. So if we're dealing with a fourth quadrant angle, one of the things that we can look at here as we try to find our double angles here, the sine of 2 times theta, the cosine of 2 times theta, and the tangent of 2 times theta, all of these can stem from a triangle. And I'm going to have it facing downward because it's going down into the fourth quadrant. Okay, so the cosine of theta was equal to 5/13. So cosine being the adjacent over hypotenuse, then we're going to have adjacent over the hypotenuse is going to look like this. So we need to use a Pythagorean theorem then to determine what the length of our other side is. Obviously this isn't drawn to scale in any way, shape, or form, but if I take 5 and I square it, I get 25. 13 squared is 169. The difference between those two numbers is 144. So the other side, the opposite side there, is the square root of 144, or 12 units. Okay, so I've got a triangle that's a 5, 12, 13. It's actually one of the special triangles. And let's use that information now to figure out what our double angle identities are equal to. Okay, so cosine of theta is going to equal 5/13. Sine of theta, which is the opposite side over hypotenuse, is going to be negative 12/13. And there is we have to remember that that angle that we're looking at, it is in the fourth quadrant, so the sine is going to be negative. And I could have drawn on that triangle, I could have drawn that with a negative 12. Although we don't usually measure distances as negatives, I could have added the negative to it and to give us a sense of direction. Okay, so anyway, let's get back to this and let's do some substitution here. So I'm taking a look at sine of 2 theta, which is equal to 2 times sine of theta cosine of theta. Do a little bit of substitution here. I've got 2 times negative 12/13 times the cosine of theta, which is 5/13. Okay, and now I'm going to have a bit of simplification here to do. The 2 times negative 12 is going times 5. I've got, let's see, negative 120 over 169. Cosine of twice the angle, let's see, if I do a little bit of substitution with this, do the same type of thing here. I've got 2 times. Now I'm going to have cosine squared, so I've got 5 times 5/13 squared. And then I'm going to be subtracting 1. Well, I know I'm going to end up with a denominator of 169 when I square that first number there. So let's just write 1 as 169 over 169. Okay, so 5 squared is going to be 25, times 2 is 50, so 50 minus 169, 1/69. So I have 119 negative 1/69. Okay, that's what the cosine of twice that angle is. Alright. So then tangent of 2 times theta, I'm going to use the information we already have with the sine of 2 theta and the tangent of 2 theta to be able to simplify this. So if the sine is negative 120 over 169, then the cosine being negative 119 over 169, I take those two fractions, I divide them by each other. Well, I can flip the, I've got tangent written down. No, that's not what I want. That's not true. That should be cosine of 2 theta. A little brain fart I had there. But anyway, it's sine over cosine. And when I take the sine over cosine, I end up with a negative 120 over 169 times 169 over negative 119. The 169's cancel each other out, and I'm left with 120 1/19. So there you have it, a last double angle identity. Feel free to check out the other angle identity examples that I have for you guys, and you have yourself a nice day.